Now, okay. All right, so here are the topics for today. We're going to talk about a statistical test, which you've certainly heard about, definitely in statistics class, one sample t-test, maybe even probably in research methods as well. It's the statistical method that I'm going to have you do for the Lab 7 Part 2 assignment, one sample t-test. We'll also talk about these two articles, the second of which, Stat Learning 2, uses a one sample t-test. So the theme of today is kind of one sample t-test. And we're going to talk about how we're going to use the one sample t-test for the lab that we just did Friday. And then we'll talk a little bit about Stat Learning 2, which also used a one sample t-test. First, I did want to talk a little bit about your tests. So I have information regarding the class for test 1. Yeah, so 31 participants, or 31 students took test 1. We had the two sections, the multiple choice and the short answer sections. And the multiple choice section, there was 33.36 points possible. I believe each question was worth 1.6 points. The average grade for the test was solid, 85%. Though that was actually, average grades on tests oftentimes are lower than the median, because if there's one or two outliers in terms of being very low, that will drag down the class average. And so the median is oftentimes a more accurate measure of the performance of the class. But the median score was an A-, 90.5%. The grade breakdown was 19 A's, which I really enjoyed seeing that. 4 B's, 2 C's, 2 D's, 4 D's rather, and 2 F's. So obviously I'm not a, I wish everyone could get A's or more, I definitely, C's, D's, and F's definitely are disappointing. But I'll point out on the optimistic side, the good side, over half of the class got A's. And if you are one of the students who scored, definitely the C's, D's, or F's, I definitely invite you to talk to me, and we could help come up with a game plan together to help you perform better on the second half of the course. And I'm going to talk about that a little bit here in a couple slides coming up. So here, that was the multiple choice section. Here is the short answer section. The average grades here were lower, but the median grade was slightly higher than the multiple choice section. So the average grade is out of 7 points. The average grade was a 5.8 out of 7, which is a 83%, which is basically a low B or high B minus. But the median score was notably higher than the average score. It was an solid A minus again, 91.4. 17 A's, so still the majority of the class actually got A's, but you can see the rest. There were some non-A's as well. Basically, about half the class got A's, and the other half of the class got something lower than an A. So overall, I'm happy to see all of these A's. There's definitely room for improvement down here. Once again, if you're one of the individuals that didn't get an A, I would be happy to meet with you and talk about your test and strategies that we could use going forward to help you improve on the tests. I wanted to also share some I did some statistical analyses on, basically I did 3 correlational analyses. And the motivation for this was when I was working at Augustana College, when I was fresh out of graduate school, my first job was at a liberal arts college in Illinois, Augustana College. And I remember quite clearly, learning about how to be an effective instructor. I was talking with the chair of the department. We were walking outside one day and we were talking, and I guess I had like one of those light bulb moments. It seems so obvious now, but at the time I remember kind of the light bulb moment was when you're making assignments throughout the course of the semester. You want to make it so that those assignments are as most effective as possible at helping the students prepare for the test that they will take over the topics that they're learning about throughout the course of the semester. And so one of the major assignments, one of the major concepts or the components of this course is the quizzes that you guys take over the articles. The articles appear on the test, and there's some of the questions on the articles are covered on the test, but we also have the Blackboard quizzes about each of those articles throughout the course of the semester. And I've tried to design this course, kind of consciously trying to design the course so that the quizzes that you take are covering the same concepts that you will in a different form, but you're covering basic concepts over those quizzes that you'll also be tested about. And the reason I'm doing that is because I'm trying to make it so that when you're taking the quiz, it's getting that information into your brain and making it so that you'll perform better on the test. I'm trying to make the quizzes themselves kind of effective study methods for the eventual test that you're taking, which makes the prediction, if my quizzes are helping our effective study tools, that would make one of the predictions would be is that the quiz scores should be significantly correlated with scores on the test. And so that's what is shown here. The x-axis is your average quiz score. So I took all of the quizzes over all of the articles that you guys read, and there was like probably 15 of them or so, not counting Hemifield 1 and Dichotic 1, because I don't, if I recall, those aren't even, those were not due until after the test. So those were not included. All of the quizzes that were due before the test, I took the average of all of those quizzes. That's the x-axis. The average quiz score is the x-axis, and then the y-axis is points on the multiple choice part of the test. And you can see that there's a positive correlation here, such that people whose average grade on the quizzes is better than for people whose average grade is high on the quizzes also tend to get high grades on the tests. And if you look, these are the R values. So Q stands for average grade of the quizzes, and then TMST stands for test multiple choice. So this is the R value right here, the average quiz score with the average, with the quiz scores correlated with scores on the multiple choice portion of the test. The R value was 0.75, so a strong positive correlation. The higher you score on the quizzes, the higher you tended to score on the test. Same here for the short answer part of the test. Here's in fact, slightly stronger R value over here. So once again, the quiz score is down here, your average quiz score. And then your performance on the amount of points you achieved on the short answer part of the test. Once again, a strong positive correlation. Students that performed well on the quizzes also performed well on the short answer part of the test. So a strong correlation right there, which I'll point out, it supports my theory or my attempt at designing this class to make it so that the quizzes are helping you get better at this class. They're helping you learn the information that you will eventually be tested on. So I have one more correlation to show you, which is right here. This is the correlation between points on the multiple choice part of the test and then points on the short answer part of the test. And these should be correlated as well, and they are. High correlation of 0.78. People that scored high on the multiple choice part of the test also tended to score high on the short answer part of the test. So it's not a perfect correlation, obviously, but in general, if you did well on one part of the test, then you did well on the other part of the test. So the in-class discussion assignment today actually has to do with these correlations, and I'll talk more about that at the end of class. Any questions or comments about them right now? Okay, so now we'll move to talking about the one sample t-test. So this is something you learned about in statistics, but the t-test seems to be that a type of t-test that students have a lot of trouble understanding. I believe the main reason that students have a hard time understanding the one sample t-test is because it's so dramatically different than all of the other t-tests and hypothesis tests that you learn about in statistics classes. So the thing which is weird about the one sample t-test is that it only has one condition, basically. And comparing that with within subjects t-test or between subjects t-test, where you're always comparing, well, does anyone remember? Let's just see if, I don't think the answer's here. So yeah, I could ask you guys this. How many means are compared with a between subjects t-test? How many conditions are there in a between subjects t-test? We have a chat here. Let's see what this says. And the answer is 2. Thank you, Abigail. The answer is 2. In a between subject or within subjects t-test, you always have 2 conditions, And for those t-tests, you're comparing the means in those two conditions to see if they're significantly different. That is not the case in a one sample t-test. This is what is weird about a one sample t-test, is that there's basically one condition. And if there's only one condition, you might be asking, then what are you comparing the mean of that one condition to? What are you comparing it? And the answer is chance performance. The mean score in that one condition, which is the sample mean, is compared to chance performance. In statistics class, they probably didn't talk about chance performance that much. If you took my statistics class, I tell you a little bit about chance performance, but this is not usually the way. Chance performance is usually not necessarily the term which is taught about in one sample t-tests in statistics classes. It's actually pretty rare for reasons I don't completely understand. But instead, they just talk about in statistics classes population mean, mu. Chance performance is, and I'll give you some examples to help you understand what this means. One sample t-test is comparing the sample mean, the mean of that one condition, to chance performance. And chance performance is that so-called population mean, or mu. And we're asking the question, is the sample mean significantly different than mu? Is the mean of that one condition significantly different than chance performance? In chance performance, it's not based on data that you collect. It's based on math. It's based on basic probability theory. And the one sample t-test, as I mentioned earlier at the beginning of class, you'll see this in Stat Learning 2. In Stat Learning 2, I noticed they called it a single sample t-test instead of a one sample t-test. Those are the same thing. One sample t-test, single sample t-test, the exact same thing. And we are also going to do a one sample t-test for Lab 7, Part 2. So yeah, let's see. We'll watch this video. I'm not going to watch. It's like a 10-minute video. I think we'll probably watch like 5 or 6 minutes of it. What this video is it's an explanation for Stat Learning 1. Stat Learning 1 was published in the journal Science. And as they say in the video, it's been cited over 4,000 times. So it's a hugely important study published in 1996 in Science. And it's kind of the basis for what we did in Lab 7. And it also provided the basis for what the researchers did in Stat Learning 2. So here's a video about Stat Learning 1, which is the basis for the other article that is on the syllabus for this week, Stat Learning 2, and for the lab that we did on Friday, Lab 7. So let's go ahead and watch this video. Can you hear the video? Could you hear that just now?
Yeah. Yes.
Good. Was it overly loud?
No, it was fine.
Okay, good. I don't want to kill your ears. All right, so I think it starts at around 13 seconds or 14 seconds. I'll start it here. And then we're not going to do the whole 10 minutes. I think we'll probably go through 5 or 6 minutes and then I'll kind of stop it in the middle.
This video is going to explore Safran, Aslan, and Newport, 1996. This is an article that really looks at how infants learn to develop language skills. I know it doesn't sound like that because the name of the article is Statistical Learning by 8-Month-Old Infants. And when we hear the word statistics, we think of like variance and means and averages and probabilities. That's not necessarily what we're talking about here. What we're talking about is a little bit different. So a little bit of background on this is that this article was published in Science in 1996, and it is incredibly popular. To date, it has over 4,000 citations from different kind of peer-reviewed articles around the world, so it's been very influential in the fields of cognitive psychology and developmental psychology. So before we even talk about the results or the theory behind statistical learning and how it relates to language, what I want to do is I want to go through the methods with you. I want to give you exactly what the 8-month-old infants in the study got, so that way you can kind of see what it's like, what they're exactly testing for. So this next part, what I want you to do is I want you to listen closely for 2 minutes. This is going to be very uncomfortable because you're going to hear basically a lot of gibberish for 2 minutes. That's okay. Try to stick with it, and I'll check back in with you after 2 minutes.
Bi go ku bu la do ta du ba da ti ba bu la do ta du ba bi go ku da ti ba bi go ku ta du ba da ti ba bu la do bi go ku ta du ba bi go ku bu la do bi go ku da ti ba ta du ba bu la do da ti ba bu la do ta du ba bi go ku bu la do da ti ba bu la do ta do ba da ti ba bi go ku bu la do da ti ba ta do ba bi go ku ta do ba da ti ba ta do ba bi go ku da ti ba ta do ba da ti ba bu la do bi go ku da ti ba ta do ba bu la do da ti ba bu la do bi go ku ta do ba bu la do da ti ba bu la do ta do ba da ti ba bi go ku bu la do bi go ku ta do ba bi go ku bu la do da ti ba ta do ba bi go ku da ti ba bi go ku ta do ba bu la do da ti ba ta do ba bu la do bi go ku ta do ba bu la do da ti ba bu la do bi go ku da ti ba ta do ba da ti ba bi go ku bu la do ta do ba bi go ku da ti ba bu la do bi go ku bu la do ta do ba bu la do da ti ba ta do ba bi go ku da ti ba bi go ku ta do ba bu la do da ti ba ta do ba bi go ku bu la do ta do ba da ti ba bi go ku bu la do ta do ba da ti ba bi go ku da ti ba ta do ba da ti ba bu la do bi go ku bu la do ta do ba bi go ku ta do ba bu la do bi go ku da ti ba.
All right, thanks for hanging in there. What you just experienced was exactly what the infants in this study experienced as well. You sat there and you listened for 2 minutes to basically gibberish, right? An artificial language. So that's what they did in the first part of the study. The second part of the study, though, is dedicated to testing how much you retained from that gibberish you just heard. So what I'm going to do is I'm going to play 16 different syllable pairings for you. It's going to be gibberish again, but what I want you to do is to take out a pen and paper, or even just a notepad or something you can type into, and I want you to type whether or not the syllable pairing that you hear is from this artificial language or if it's not from this artificial language. So you should be writing down yes or no for these 16 pairings. I'm going to play this. It's going to last about 2 minutes, and I'll check in with you in just a moment.
Bu la do la do bi ti ba ta do bi go bi go ku.
All right, I think that's probably good enough. Well, okay, so that was the stimuli from Stat Learning 1. So I'll kind of summarize some things here, and then we'll talk about their data analysis, and then we'll talk about some of the studies, including the one that we did on Friday, which sprang from this. So yeah, you heard the 2-minute familiarization sequence, and it was composed of syllables, in that familiarization, it was composed of words. What words was basically 3 syllables that were connected together. And the entire familiarization was composed of apparently the same 4 words played over and over and over in a random order. One that stuck out to me was bidaku. Every time that they said bidaku, that one stuck out to me. That was the one that I could hear very clearly. So there was a certain amount of, there was words, which were 3 syllables, the same syllables, and they would always occur in the same order, bidaku. They would occur, 4 different words appeared throughout the entire familiarization. And then you also experienced a little bit of what the infants did. In the test trials, infants were presented either one of those words, like bidaku, or so that would be considered a word, or they were a 3-syllable word that was not from the familiarization. So they were presented either a word or a non-word. And during the test trials, that word or non-word was repeated over and over and over again. So a word would be bidaku, 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 bidaku. And the dependent variable in the study was the amount of time that the infant spent looking over in the direction of the word during the test trial. So once again, they would repeat the word over and over and over again during the test trial, or they would repeat a non-word. A non-word is one of the words that was composed of the same syllables that occurred during the familiarization, but the syllables did not occur in the specific order that they occurred in a given word. So example of a non-word would be, bidaku was a word, but if you just rearrange those syllables to ku da bi, that is a non-word because that sequence of syllables never occurred during the familiarization. And so during each test trial, the infants would hear either a word over and over again, or they would hear a non-word, the same non-word over and over again. The dependent variable was the amount of time that the infant spent looking over at the speaker that was producing that word. And this is, if you've taken a developmental class, you might be familiar. This is a very common way of studying infant behavior. Infants can't talk. They can't say yes or no. They can't say, yeah, that word was in the familiarization, or no, that sequence of syllables was not in the familiarization. The infants can't do that. So instead, they just look at how long did the infant spend being interested or looking at the thing which is producing that word. And the assumption was that infants would spend more time listening to the non-words because they were new, they were novel. The stuff that they heard in the familiarization, like bidaku, that was the word, they heard that so much that it's like boring. It's not interesting to them anymore. And so they assume that once you get to the test trials, the words that the infants would be most interested in will be the words that they did not hear previously, the new words. And novel is just a synonym for new. And I think we have the data right here. Yeah, here are the data. This is copy and pasted directly from this article in Science from 1996, Safran et al., 1996. And they did have two experiments, experiment 1, experiment 2, and the experiments were very, very similar. And they also showed basically the exact same pattern of results. So the dependent variable here is the amount of time looking at the two different types of words. So there were familiar items, those are the words. And then there were the novel items, those would be the non-words. And as you can see here, they spent on average in experiment 1, for instance, 8.85 seconds looking in the direction of the novel words when they're being produced during the test trials, and 7.97 seconds at the familiar items, that is the words, during the test trial. So 8.85 is bigger than 7.97, and those differences were significant with this t-test, which was a within subjects t-test. A paired t-test is the same as a within subjects t-test. They were comparing the means of these two different conditions, and they found a significant difference. And they found the same pattern of results in experiment 2. The infant spent more time looking at the novel, that is the new words, the non-words, compared to the words or the familiar items in both experiments. Each experiment used a within subjects t-test comparing the means of those two conditions. So this is kind of the study that started the entire field of statistical learning. And as they said in the video that you just watched, it's been cited many, 4,000 is actually more than I realized. That is really, really high impact study. So this leads us to statistical learning 2, stat learning 2 study. This is also one of your reading assignments for this week. It's also very, very close to what we did Friday. So the idea of these were the Safran et al. 1996 in Science, that was using speech syllables. The question that was examined in Stat Learning 2 was, do you get the similar type of statistical learning where people can, or infants, or adults can kind of abstract the words, or in this study, the tone words that are appearing repeatedly in that familiarization sequence? Are they able to learn those words or those tone words, as in this study, that occurred to that familiarization sequence, so that when it comes to the test trials, the participants are able to differentiate, yeah, this is something that I heard in the familiarization, this is something new, this is something that I didn't hear in the familiarization. So in Stat Learning 1, the participants were all infants. In Stat Learning 2, they actually have multiple experiments where most of the studies are in adults, but I do believe they have one study in Stat Learning 2, which is on infants. And so in this study, the stimuli were all toned. So everywhere in Stat Learning 1, everywhere in the Safran et al. 1996 study where there was a syllable, in this study, there's a different tone or a different pitch. So it's like musical tones or musical pitches in this study. And instead of having words, the familiarization contained tone words. So a tone word was a group of 3 notes that occurred in a given sequence. And that given tone word occurred somewhat repeatedly throughout the course of the familiarization. It was one of several different tone words that would occur over and over and over again throughout the course of the familiarization. So this is something that I need to say because it will help you understand. If you don't, it might confuse you on the figure I'm about to show you. There was 2 different familiarizations that were used in Stat Learning 2, but they basically showed the exact same pattern of results. And the difference between the two familiarizations, in one of the familiarization, there was 1 set of tone words. In another familiarization, there was a different set of tone words. But the results of the studies showed the exact same thing. So there's really no significant difference between the 2 familiarizations that they used. There's a little bit of a difference in the test trials in Stat Learning 2. And most important for us, there's difference in the statistical technique that was used in Stat Learning 2. They used the 1 sample t-test in this study. So on test trials, there was a short melody. It was a 3-tone melody that occurred. There was 2 of them. One of those 3-tone melodies was a tone word that occurred earlier in the familiarization. The other 3-tone melody was a non-tone word. It was a sequence of 3 notes, and all of those notes occurred during the familiarization, but they did not occur in that specific order. So the tone words were 3 notes that occurred in the same sequential order as they occurred in the familiarization. The non-tone words were 3 notes that did not occur in that specific sequential order during the familiarization. And so participants' job was to choose the melody out of the 2 choices that occurred in the familiarization. In other words, the participant's job was to choose which of these 3-tone melodies is the tone word, and then, yeah, that's it. Which of these 2 choices is the tone word? Which of these 2 short little melodies occurred in the familiarization sequence earlier? This is exactly what we did for Friday's lab. So here are the results of this study right here. Once again, I said that there was 2 familiarization. So familiarization 1 and familiarization 2. But they show the same thing. So we're not comparing these 2 things. And I don't want you to be confused about that. The important thing in this study is not comparing the difference between these 2, because there was no difference between these 2. They both showed the same result. So really what you need to do is like focus on just one of these. Focus on either language. Just focus on this part right here. And what we see here on the y-axis, this is the amount of correct trials out of 36. And remember, on each trial, they were given 2 choices. One of those choices was correct. One of those choices was not correct. One of those choices was a tone word. The other choice was not a tone word. And so it's getting back to the thing that I talked about earlier about chance performance, probability. I want someone out there to tell me, if you have 2 choices on a problem, one of those choices is correct, the other one's not correct, and you have to guess on that problem, what is the likelihood that you will correctly guess the answer? Someone tell me that. 2 choices, one of them's correct, one of them's incorrect. You have to guess. What is the likelihood that you will guess correctly? I have a chat. Let's see what the answer is here. And I do have, the correct answer would be 50% of the time you will guess correctly. And the reason is because 1 divided by 2, the 1 answer is correct. There are 2 possible answers. 1 divided by 2 is 50%. And you see right here, it says chance performance right here in the figure. And that's this line right here. And if you look, that line goes to the number 18. Goes to the number 18 right there. And so chance performance in this study would be getting 18 trials correct. Can anyone figure out why is 18 trials chance performance? Getting 18 correct, out of the things I've told you, and you can see in this figure, why is 18 trials, why is that considered chance performance? Anyone tell me? It does have something to do with this 50%, but 50% of what? I'm not seeing any action here, so I'll just tell you. 36 total trials. Oh, well, now we do, of course. Oh, good. Thanks, Abigail. Yes, 50% of 36 is correct. That gives you 18 right here. So 18 is chance performance. There's 36 trials. If on each one of those trials you have a 50% chance of getting right, then if you apply that to every single trial, out of all 36, if you were guessing on each of those 36 trials, then chance performance, guessing on every trial, you would expect on average, people that were guessing would get 18 of those 36 trials correct. 50% of 36 is 18. That is chance performance. They performed a one sample t-test for language 1, that is familiarization 1, and what they were doing was they were looking to see, is the amount of correct answers significantly different than chance performance? Chance performance was 18. These black dots right here, that each one of those represents a participant. So let's see how many, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like there was 12 participants, the small sample size in this study. 12 participants, and they were looking to see, does the average score, which was the average score is represented by this triangle, is the average amount of correct responses of these 12 participants, is that average score significantly different than chance performance of 18? And that's what they did, the one sample t-test. And the answer, by the way, is yes. And you'll see that. I don't think I copied and pasted that but you'll see it when you read Stat Learning 2 and you read, I think this is experiment 1, you will see that the one sample t-test compared performance, the actual sample mean, which it looks to be around 26 or 27 correct answers, was significantly greater than chance performance of 18 correct answers. So what this suggests is that in this study, these were adult participants, they were able to differentiate between the tone words and the non-tone words significantly greater than chance. They were not just guessing, they were doing better than guessing. They actually knew what the correct answer was more than just guessing. And then they found the same thing for language 2, as I said. These two studies found basically the same pattern of results. The adults could figure out what was a tone word and what was not a tone word during the test trials. So that leads us to lab 7. The exact same thing, almost, I don't want to say the exact same thing. There was a couple small differences compared to Stat Learning 2, but basically for lab 7, I replicated as close as possible for us the stimuli and the task that was performed in Stat Learning 2. So you listen to a 2-minute familiarization sequence, though you listen to it twice. And that familiarization sequence composed of 6 notes. They're from the whole tone scale, if that means anything. In case you're curious, the whole tone scale is oftentimes used in like movies when a person is dreaming. And so those were the 6 notes: C, C natural, D natural, E natural, F sharp, G sharp, and A sharp. Those were the 6 notes. You heard those 6 notes. Those are all the entire familiarization that you heard during Friday's lab was just tone words that were created from those 6 pitches. I created 4 tone words, and those tone words occurred over and over and over again throughout the familiarization. And the question, and then on each test trial, you would hear 2 stimuli. One of them was a tone word which occurred during the familiarization, a sequence of 3 pitches that occurred during the familiarization. The other was these 3 pitches, but they occurred in a sequence, an order that never occurred during the familiarization. Your job was to choose which of the 2 stimuli in each test trial occurred in the familiarization. So just like in Stat Learning 2, when you guys were performing lab 7, you had a 50% chance of getting the answer correct. Of course, you only performed 4 trials, so chance performance for you was 2. If you were guessing, on average, you would expect a person to get 2 trials correct. Because we had 4 trials, 50% chance on each trial, 50% of 4 is 2. That would be chance performance for our study. Here is our Google Sheet. So last time I looked at this, 25 people had posted their data, and that's still the way it is. So the average score was 2.4. And so the question that we're going to have is that 2.4 based on these 25 people, is that significantly different than 2? 2.4 is our sample mean, but we want to compare it to chance performance of 2. Is 2.4 significantly different than 2? And also, this will be relevant to what you guys are going to do for Lab 7 Part 2. You can convert each one of 4 is the amount. This person got 4 trials correct. This person got 4 trials correct. This person got none of them correct. This person got 3, 2. These are the amount of correct trials out of 4. You can convert those scores to a proportion. And so 4 out of 4 is 100%. 4 out of 4 is 100%. 0 out of 4 is 0%. 3 out of 4 is 75. 2 out of 4 is half or 50. So over here, I've just converted all of these to the proportion correct. And you can see it over here. The average, this is basically like per percent. So basically the average percentage correct was 60%. People got 60% correct on average. And so you could analyze these data and compare them with chance performance of 2, or you could use these data and chance performance would be something different than 2. And I'm going to want you to think about that for Lab 7 Part 2. I'm not actually going to give that answer. For these data, chance performance is 2, but if you convert everything to a percentage, what would you be comparing it to for chance performance? So I'm not going to give you that answer. I want you to think about it and try it on your own for the lab. So what I'm showing you here is how to perform a one-sample t-test in SPSS. And I'm going to show you how to do it for the amount of correct. So remember, there's 4 trials, and on the Google Sheet, the left-hand column shows you the amount of trials correct out of 4. That is what is right here on the SPSS. This is the amount of correct per trial. Over here is the proportion correct. So I converted these numbers, 4 divided by 4, once again, is 100%. 4 divided by 4 is 100%. So these numbers over here are just transformed from over here. These are the corresponding proportions over here. I'm going to show you how to do the one-sample t-test, comparing the data to the chance performance of 2. What you're going to have to do for Lab 7 Part 2 is compare these data right here to whatever chance performance is for the converted scores. These are all converted to proportions. What proportion would represent chance performance? And I don't want you to say that loud because I want you to have to think about it on your own for Lab 7 Part 2. So that's the way that I set up the data. You don't have to set the data up exactly like that. Do I hear a question out there? I hear some noise. I don't think so. Okay, continuing on. Here's how to do it. So analyze, compare means, one sample t-test. The amount correct is what I'm going to show you how to do. And this is important, and the most common error by far when students perform one sample t-test is leaving the test value blank. The most common error by far. Every single time I've ever taught a stats class where we do one sample t-test, there's always multiple students that leave this blank. It always happens. I hope it doesn't happen this time, but it probably will. So hopefully not. So the test value, when you're comparing the amount correct, remember the average amount correct was 2.4. The test value is chance performance, 2. If people were guessing on each trial, then the average amount correct per participant would be 2. We want to do a one sample t-test to determine, is 2.4 significantly different than chance performance of 2? You set it up this way, press OK. Here is the output. And we are close to significance. We got 0.106. P-value in psychology usually is considered 0.05. I've actually done this exact study with a larger sample size, and it did reach it did eventually reach significance. So one of the problems with doing these lab exercises is our sample size is usually going to be pretty small. So it didn't reach a traditional level of significance, but I basically guarantee that if we doubled the sample size, it would become significant, because I've done this exact study before, and it did become significant. It was a pretty strong effect size. So this is the output. Here's the t-values, degrees of freedom. The p-value is right here. There's that sample mean, 2.4. There's the sample size. This number right here, the mean difference, is taking 2.4 minus chance performance of 2. 2.4 minus 2 equals 0.4. So you're going to have to do a similar thing for for the proportions. And here are the answers for it. But I have my watermark. But what you're gonna have for your Lab 7 Part 2, you're gonna have to reproduce these outputs on your own, and you'll have to copy and paste them without the watermark right there. And that will be what you turn in for Lab 7 Part 2. And these are the right answers. So you already know what it's supposed to look like. If more people come and there ends up being 26 or 27 participants, it might be slightly different, but it's going to be, if you have the 25 participants, this will be exactly what it looks like. If the sample size is a little bigger because people add the data, it'll be close to this, but it will be slightly different. But these are basically what the right answers are going to look like for Lab 7 Part 2. And then finally, here are the 2 assignments for today. Here's the in-class assignment, which I mentioned earlier in class, that has to do with those correlations I showed you regarding your test performance. So I want to hear some potential, you should have learned in research methods about the idea that you cannot infer causality from a correlation. And that's kind of what I erroneously did when I was showing you those correlations. I basically made the claim that doing well on those quizzes, it causes you to do better on my tests. You know, that's when I was at Augustana College, I really wanted to design good assignments during the semester so that students do well on the tests. And so because I want to believe that, I'm highly motivated to believe that it was the reason you did well on the test was my quizzes. But there are alternative explanations that even though there was definitely a strong correlation, people that did well on the quizzes also did better on the tests because of problems related to third variables and correlations. There are other things that might explain the correlation between quiz scores and tests other than the idea that doing well on quizzes causes you to do better on the test. There are alternative explanations for in-class assignment. You have to come up with, I think I said, 2 alternative explanations for the strong correlations between the average quiz score and the test performance other than this explanation that I provided right here. So you'll turn that on into Blackboard, and I will make that due, let's see, what day is today? Monday. I'll make that due Tuesday at 11:59 p.m. And here's the other assignment for today, Lab 7 Part 2. I've already showed you basically what the output's going to look like. You're going to analyze the proportions from Lab 7. So these are the proportions, once again, are the data on the right side of that Google sheet. The decimals, those are the proportion, those things that were decimals. You will analyze the proportions using one sample t-test, comparing the average proportion to chance performance. The average proportion was 0.6. What you do have to do is think carefully about what chance performance would be for the proportions. For the amount correct, chance performance was 2. But when I transformed the amount correct to proportions, chance performance is not going to be the number 2. It's going to be something else. And I will give you a clue. It's a number that has a decimal in it. You will copy and paste your entire output into a Word document, and you will turn that into Blackboard. This will be due Friday at 11:59 p.m. I think that's all I've got for today, so I will stop recording now. And you guys can get to that. I will be around my computer for a while if you guys